and then I'll take over from the demo point at the end. All right. As Graham said, this session is going to be recorded, so please keep your microphone muted so that everyone can hear. But as Graham nicely put it at the start, what we're going to have is we're going to have a workshop with 5 separate sections, and if you want to ask questions at the end of each section, please do so. So unmute mic and ask your question, or you can ping it in the chat. Phil's going to be keeping an eye on the chat, so if you've got anything you don't want to say but you want to write it down, the chat's also available in Teams. You can ping it in there as well. But this session will be recorded, so start the recording now, and we'll send that out at the end as well. Okay. So what we're going to look at today is we're going to do an introduction. We're going to have a look at the product overview. We're going to have a 10-minute comfort break, just so we can let all the information of the product overview sink in. The pre-LC and the drive integration demonstration, followed by questions and wrap up at the end. It will be about 2.5 hours. So apologise if it goes on a bit, but there's a lot of detail that we need to fit in. So at Siemens, when we're talking about motion control, we're going to take this machine as an example, and we split the type of motion into 2 separate sections. One section is our continuous motion. As you can see, the areas highlighted in green are just turning continuously. These might be run at fixed speed, they might be run at variable speed. If we want to speed the whole machine up, then these are going to have to be run by a variable speed drive to make sure they change the speed according to the line speed of the machine. Then we've got discontinuous motion. So as you can see, the areas now highlighted in yellow orange, these are like very start and stop. So we split our motion to 2 different types, continuous motion and discontinuous motion. Everything we're going to look at today is sort of continuous motion type application. We have a separate workshop that we're hopefully going to run on the back of this, which is going to be discontinuous motion. We have a whole range of motors that fit into our continuous motion range, and a whole host of motors that fit into our discontinuous range. So we've got our general purpose motors, Simo gear geared motor range, and then we've got our 1FK6, which is our servo range. We've got even torque motors and then special linear motors as well in our discontinuous motion range. So we have a whole range of motors that suit all of our motion applications. Controlling these motors, then, we're going to need a whole raft of drives. So we have low-end, low-performance drives such as the SINAMICS V20. We have the G120 range of drives, which very much is the breadth of the portfolio. The G120D, which, as you can see by the diagram or the picture there, is like a wall-mounted drive, high IP, so it could be bolted on the side of a conveyor on a wall. And then we've got the G110M, which normally comes in this sort of Simo gear arrangement. So we've got a geared motor solution with the drive sat right on top as well. So that's the G110M. So there's our range of drives for our continuous motion platform. We're going to look at the G120C today, but the principle of what we're doing fits with most of the drives in the portfolio. And then in our discontinuous range of drives, we have the V90 low-end servo drive, the S210 mid-range servo drive, and the S120, which is our high-end servo drive as well. So as you can see, we have a whole drives portfolio that suits different parts of the application as well. How are we going to control these? Well, the perfect pairing, of course, here is Simatic and SINAMICS. So this is the perfect pairing. We can have S7 1200, 1500, or a Simotion D or Simatic drive controller at the front end. Then we've got our range of drives to suit all of our applications, and then the suitable motors as well. Is there anything to add on that, Tim? Or
no, I don't think there's the next slide. Will show the guys a little bit more about the breadth of range.
Absolutely.
This looks a little bit confusing. What we've done on here, this is a brochure picture, so it's taken the breadth of the product from the basic, so the V20 on the left hand side, all the way up to the, I'd say, more complex applications. But if you now see SINAMICS at all, you'll see that the V20 is a cost-effective, reliable, packed full of features, minimal comms, but then you'll jump up to the G type drives that we're talking about today, where you'll get a lot more save to off functions, SS1 functions, limited speed functions, things like that. And also the comms functions in the G drives are a lot more comprehensive than the V. But we're going to concentrate on the C today, the G120C, which is a compact drive. We'll probably do most of the applications that we'll talk about today and your applications back in your workplace, up to about 132 kilowatt. So it's a compact drive, no modules to fit apart from an operator panel or however you decide to control the drive. So the operator panel will fit on the front, but that's the only difference on the G. We're concentrating on AC drives in our team, all the way up to the S drives on the right-hand side, which is the servo, multi-axis, multi-function drive. So, but we're not going to cover that today. It's just there to show you the breadth of range we've got in the AC product from Siemens in SINAMICS.
Brilliant, thanks, Tim.
Next slide, I think. Back to you.
Yeah. So what we're going to look at here is if we're looking at our SINAMICS VG in a pumping application, then we can connect via Profinet, Profibus. We have the different options for a moving application. We might look like it down a distributed bus like ASI, for example, Profibus, Profinet. Obviously, the advantage of Profibus is we've got longer cable lengths. So if we had a huge distribution warehouse or distribution center and we need a really long cable length, we might opt for Profibus over Profinet. And as you can see, as we move up the complexity of the application, or you can connect all of this into our control level. So all of this via Profinet, Profibus into our automation platform. And then, of course, we've got our supervisory control right at the very top, and then we can even integrate into the IT platform as well. So it's just showing the hierarchy of on the integration of our products. If we touch on HMIs, we have a scalable range of HMIs. Right down at the base or the bottom level, we have keypads, which are literally just 8 or 32 cut out push button panels. We have basic HMI panels. We've got our comfort range of panels in both mobile format and stationary format, right the way up to PC based automation. So we've got a scalable solution to suit effectively any needs in the market. Similarly to our HMI portfolio, then we also have a scalable PLC portfolio where we've got this S7-1200 down at the bottom end, and then the S7-1500 advanced controller up at the top end, split into two sort of sections where you've got the ET200 SP variant, and we've also got then the full-blown S7-1500 PLC as well. As you can see here, we've got a scalable solution moving up complexity as we move up the portfolio. As Tim touched on earlier, here we've got our SINAMICS V20. This is for our continuous motion range down at the bottom end, and that scales up to our SINAMICS G120C or G115. We've got the G120X in there for our pump and fan specialist. We've got the G120 and G120D. So G120 is our modular version of the G120C, where we've got different parts, power modules, control units. And the G120D is our distributed version, which then can sit, as I said, bolted on a wall or on the side of a conveyor. And then right at the top end, we've got our S120 as well, which we can also use for our continuous motion portfolio. As you can see, the V20 here sits outside of our TIA portal, so that does not integrate into our TIA portal. So we've got a slight disadvantage versus the rest of our drives where you've got full integration into TIA portal. So we're going to look at the G120C and integrating and engineering that in our TIA portal today. What we've got here is basically a list of features up on the left-hand side and seeing where the products fit and what features we have. So if we wanted, you know, we've got a really cost-sensitive solution, but we want Profinet, you can see straight away that the V20 here only has I/O or serial comms to control it, such as USS and Modbus and V2F control. So if we did want Profinet, we'd go up the portfolio to the G120C, G120P, or the G120X. And as you can see, that's now got start drive integration, some basic safety on board, Profinet, sensorless vector control. Again, if we then said, right, we don't want basic safety, we need some extended safety on this, we need something like safe stop 1, safe limited speed, we'd have to move up to the extended safety, and that then pushes up to our G120 or our G120D range. And then if we wanted multi-axis and really high performance vector control, then we're looking up into our S120. What we need to know is that effectively the drives here incorporate everything below it. So yeah, of course, the G120C can do UF control, and it can also have USS and Modbus comms. So that's an option on the G120C. So it incorporates everything else below it as well. Is there anything to add on that, Tim?
No, I don't think it does. It's just the next slide is more useful for today.
Yeah. So this, go on, Tim.
You carry on, Adam. Carry on.
No, go for it, mate. Go
okay.
For it.
Right. So we're gonna concentrate on G120C today. You've probably been a little confused that there's a lot of drives that cover a lot of applications and have a lot of features. And the previous slide that Adam showed you just pulled it out to show if you're looking at basic standard V2F control, not too worried about comms. You can start down at the bottom end in the V, but the G really covers most applications that you would look at in your environment. So G120C, as I've said, is up to 132 kilowatt. The G120 modular system goes up to 215. Modular being you pick a power module, you then pick a control module, and then you pick a keypad or an operator panel. The advantage with the G120 modular is if 9 times out of 10, if something along the line is going to fail, it will be the power stack. So it allows you to swap out and get running quite quickly rather than having to completely change the whole unit and swap it out. So that's quite a nice feature of the G120 modular that you're able to do that. G120X has probably been around for about a year or so now, probably about 18 months for the infrastructure, for the fan and pump, for the wastewater market, packed full of features and goes a little bit larger, as you can see, up to 630 kilowatt. So it's particularly fitted in that market of water, wastewater for pumps, fans and compressors. And then you've got the distributed, what we call, I'd call the distributed I/O drive. That is particularly suited to conveyor manufacturers, conveyor builders, where they want the control local to where their motor and gearbox is. So as Adam said, bolt it on the wall, bolt it underneath the junction of a conveyor. That can be distributed around the workplace. Okay, next one, I think.
So we're just not going to delve too deep on the technical detail here of the G120C. I don't think there's much merit in diving too deep, but as you can see, for example, we have one analog input on board, which can either be minus 10 to 10 volts or 0 to 20 or 4 to 20 milliamp, and we can select it. So it's not an option to swap between G120Cs. We just literally flip a switch underneath the flap there. But if we needed 2 analog inputs, you can see that straight away we'd have to go upper level, and that's where the modular drive comes in. And that's typically the difference in water. The water industry is they need 2 analog inputs, and therefore the G120C isn't too common in the water industry, for example. But you can see we've got 6 digital inputs, 2 digital outputs, 1 analog in, 1 analog out. We've got a motor temperature sensor on there as well to make sure that our motor doesn't overheat. We've also got our power supply output. So generated internally in the drive is a 10-volt DC output, which we can use for our analog inputs, and 24-volt DC output as well, which we can use to switch our digital ins. So we don't need to have an extra 10-volt power supply or 24-volt power supply in our panel. We can actually, that can be self-generated from the drive itself. It has an integrated 24-volt DC connection on the front, so we can put external 24 volts on. So if we isolate the mains, the 3-phase into the drive, we can keep the communications alive. So if you imagine you've got a whole stack of these, Profinet port in and out, looping all the comms together. As soon as you isolate one, you'd lose everything down the line. Well, if we keep this 24 volts connected to each of the drives, that keeps the communications alive, and therefore we can keep all of our drives connected to our higher level controller. You can see it supports Profinet, USS, Modbus, RTU, Profibus, and then we've got our options of the IOP, BOP, or the Smart Access module, USB port, as you can see on the front here, if you want to do point-to-point commissioning, and there's an SD card typically in the top as well, SD card slot, where we can do things like firmware upgrade and backup parameters as well. Touching on the modular concepts, as Tim mentioned, you've got your 3 parts where you've got your power module, your control unit, and your operator panel. We've got 3 different variants of operator panel, 3 different variants of the control unit, and then effectively 2 or 3 variants of the power module. As Tim said, the power module is the most likely part to fail, so this part we can take out. take our control unit off, plug it straight back on the front, and all the intelligence is stored in this control unit. All your I/O wiring, all your intelligence, all your comms is in that control unit. So we replace the power module, control unit goes back on, and we're back into operation. And obviously straight away you've got a time-saving benefit for reduced downtime there versus the G120C, where you've got everything in one housing, all the brains and everything built into one house. Looking at that portfolio in a little bit more depth, then in the modular concept, we've got our PM230, which is typical for our pump and fan market. Widely, that's typically been replaced by the G120X. We've got the PM240, which I would say does the breadth definitely of applications, and then the PM250, which allows power flow in both directions. So if we've got something where we've got maybe a lifting and lowering application, we might look to put a PM250 on there, so that can actually then send energy back up the line supply. It doesn't feed and synchronize to the grid though, so we wouldn't use it for power generation back onto the grid, but it can be used by another part of the process. So you've got two drives, one's lifting, one's lowering. As one's lowering, that's regenning back into the PM250, and then that can pass it to the other drive, which then uses it for lifting the application, for example. So we've got a bit of energy transfer between our drives there with the PM250. 3 control units, the CU230P, widely for pump and fan application. As I say, typically this has been replaced by the X. We've got the CU240E, which does the breadth of the applications, and then CU250S, which the only benefit really of the CU250S over CU240E is we're allowed to bring in an external encoder, so we can start doing some closed loop type positioning with CU250S. And then here's a little lineup of our 3 operator panels. The basic operator panel, which I think, as Tim would say, is only really good for really quickly displaying what's happening on a machine. We can really simple text readout of things like DC link voltage, but apart from that, it's not the best interface, I would say, into the drive, and I think Tim would probably agree on me on that.
No, not at all. Yeah, it is exactly what it says. It's an interface to the drive, and that is it. It's a 2-line text display. The best module Adam's just about to come on is the IOP2, which interface operator panel. It's a smart commissioning assistant. It's like having Adam or Phil Hicks with you. It's a service engineer built in a little control panel. You don't need a manual. You'll be surprised how easy Siemens drives are to program with this. You do not need a manual. It's very intuitive. The display, you can display trending. You can look at all your parameters. You don't need to know the parameter numbers. You can look at your diagnostics, or your alarm handling, or your alarm history, all in this device. It is simply a commissioning assistant and having one of Adam's team with you all the time, because it really is intuitive. And we're doing a different workshop, so we'll show you that in more detail in a different workshop. But that is a unit on its own.
Yeah. And as you see, the color display just really does give you so much more information than the 2-line text display with little graphics that we don't really know what they mean, like a circle with a cross in it, no text readout versus IOP. And then right on the right-hand side, we've got the Smart Access module, which effectively clips onto the drive, and it has its own Wi-Fi. So we then connect to that Wi-Fi module or Smart Access module with our PC, load up the web page built in, and we can do effectively everything we can do on the IOP, but on our PC or our PG or our smartphone or our tablet. The interface is entirely up to you. As long as it supports Wi-Fi communications, you can use it to then commission the drive. That is point-to-point secure Wi-Fi, so you can't have multiple connections into that one drive. It is point-to-point secured Wi-Fi between the drive and your commissioning tool. Similarly, though, we could then take that, we could store parameters, and then we could do serial commissioning with that one Smart Access module as well. So that's the modular concept. CU230P again, HVAC, pumps, fans, applications. CU240E got Safe Talk offers standard, but they do a CU240E-F, which also has extended safety. You can see USS, Modbus, Profibus, Profinet. CU250S, again, everything else, but it doesn't support this encoder connections. We can do EPOS, where we've got closed loop positioning built into the drive itself. That's an extra license though. And then we've got extended and basic safety functions on there as well. So again, we can move up the control unit portfolio, or up or down the control unit portfolio, depending on our application. What we're going to look at when we do the demonstration is we're actually going to look at setting up local safe torque off on our drive. So the G120C supports safe torque off either via ProfiSafe or via local e-stop. Beauty of the G120C is we can, and all of the G120 range drives, is we can take dual channel e-stop directly into the drive. No need for a safety relay in the middle. We can take that dual channel straight into the drive there and activate safe torque off functionality. Safe torque off being as soon as we hit that e-stop, the drive makes sure there's no torque producing currents coming out of the out of its outputs, and therefore the load just coasts to a stop. Okay, so it's not a control stop, it's not a ramp down, it is just a coast, but a safe coast to stop. Okay, so we'll look at that, setting that up. If you want to know more about safety integrated features of the drives, with the G120 modular, you see the CU240E here has safe torque off. We've got the CU240E-F, which has a whole host of safety, including safe stop 1, safe limited speed, and similarly the CU250S, which then also supports safe brake control. So we can select the correct control unit depending on the safety requirements for our application, and that's the beauty of the modular concept. Just touching dead quick on discontinuous motion, because we've not touched on it too heavily, but it's just good to make everyone aware that it's there. In the V90 portfolio, we have the V90 and the matched 1FL6 servo motor combination. Similarly, S210 and 1FK2 servo motor combination. Differences between the two mainly is this one cable technology. So you've got one cable between your inverter and your motor here, with encoder cable in it. And power cables, brake cables, and everything all in the one cable. Obviously V90, we've got multiple cables coming back. But as you have a look, we've got servo control, Profinet, serial comms, Modbus, for example, in the V90. Local safety via terminals for safe torque off, TIA portal integration. As we move up to the S210, now you can see we've got basic and extended safety, which also supports ProfiSafe. So not just via terminals, but also ProfiSafe. Start drive integration, full start drive integration, TIA portal, web server built in, and we can even do DC coupling on the S210 as well. And then again, right up at the top end, we've got our S120 multi-axis, DCC, energy recovery, the whole shebang. Just to let you know that we've got a whole portfolio there. When we're looking at then our these type of applications, so do we need a positioning axis? Then we've got to choose a suitable PLC. So S7-1200 does position and speed axis. The 1500 does position, speed axis, does coordination, so synchronizing two axes together. Relatively, we've got S7-1500T CPU, which now goes as far as doing kinematic functions with conveyor tracking. So for example, if you see the image here, you've got a conveyor with product coming down it, and then you've got this cutting machine, which is moving with the conveyor. That we would call kinematic functions with conveyor tracking, and it will be slicing the product as it's going down the conveyor. So now we can do all that inside the 1500T CPU, and right up at the top end, we've got our Motion portfolio as well. So that's what I mean by we've got a scalable solution in our PLC portfolio, depending on what our application is as well. Just going to now overlay the PLCs and the functions of the PLCs with our drives portfolio. So there you go, speed axis, position axis. We've got output cams and relative gearing in our 1500T processor, so the advanced technology functions. We've got cross PLC synchronization, kinematic functions with conveyor tracking, camming and gearing all built in. And this is how we'd probably overlay the products. You've got a V90 very much serving that bottom end. Once we get up into the mid-range, you've got the S210 doing everything from 1500, 1500T, and then right up at the top end of your motion is the S120. So that's how we'd overlay sort of the PLC and the drives portfolio. And that's what I mean by it's very much a match made in heaven, where we match the PLC to the drives portfolio as well. So right at the very end now, what do you actually want from your inverter? Well, I want to control a motor which is going to make something move, whether it's lifting and lowering this box, whether it's pumping or blowing air, or whether it's moving a conveyor. I get the motor data and I pump it in, and I just want it to control that application. Real simple. But a drive is so much more than that. A drive is so much more than that. You can have modularity, space saving, integrated drivetrain. So we can do coupling, motor, gearbox, inverter, right the way up to the PLC end. Profinet, Profibus, serial comms, basic and extended safety. We've got integrated diagnostics. We've got TIA portal integration, reusable engineering by using the library functions in TIA portal, digitalization. We're sending data from our drives directly to the cloud to be analyzed, and then we've got energy recovery as well. So an inverter is so much more than just controlling a load. It's packed full of features and functionality, and now we need to get the benefit out of them. So what we're going to do is we've got our PLC, we've got our drive. We connect these up on Profinet. So this is what the workshops or the demonstration is going to look at. So we'll touch on this. I'll just give you a quick overview of what we're going to look at. We've got two words of information. We've got our PZD1 and 2, which is our drive control word and speed set point and drive status and actual value. And these are pinging between the drive and the PLC continuously. And to control this, we're going to use our SINASpeed block. We'll look at that in a little bit more detail. We're also going to put a HMI on there so we can actually control our PLC application code and our drive directly from our HMI and look at the diagnostics. And as I said previously, we're going to have safe talk off, so an e-stop wired directly into our drive for local safe talk off. So this is effectively what we're going to look at: configuring the hardware and diagnostics, commissioning the drive, including local safety, creating the drive control block, and controlling and monitoring the drive from the HMI. They're the four sort of sections. So as I say, if you've got a question around the configuration, when I get towards the end of the configuration part, I'll ask is there any questions, so feel free to jump in at any point when we get to the end of each one of these sections. And if at the end we haven't covered something that you wanted to know, feel free to ask the questions then. And all of this is going to be engineered in the TIA portal version 16. So what we've got now is we spoke dead quick about the SINASpeed block. This is what we're going to use to control our drive. Using our standard Telegram one, so our most basic Telegram. But now we're getting so many more requests saying, I don't just want to know what speed my drive's running at, I want to know the torque, I want to know the current it's using. Well, now we've extended this SINASpeed block where we've got SINASpeed Telegram 20 and Telegram 352. And as you have a look at the pins, now we get an actual speed coming back, actual current, actual torque, actual power. And here on 352, we're also getting the warning code and the fault code. So if we had a fault on our drive, we'd get the full fault code coming back. We can then do a lookup of that fault code to get the full diagnostic details from the manual into our PLC. If we can use SINASpeed Telegram 20, if we now to set this block up, then we can set up Telegram 20 and 352 SINASpeed blocks as well. So we're just going to look at this SINASpeed block on the left hand side, the original SINASpeed block. But once we know to set that up, then we should be more than confident in setting the other two blocks up as well. What we're also going to look at is ProfiDrive standard diagnostics. Effectively, it's a tick box exercise to enable standard diagnostics. What do I mean by standard diagnostics? Well, these are our list of errors. Now, there's a whole host of these. They go on and on and on and on. I've not put them all in. But for example, if the drive had F30002 on there, so fault code 30002, DC link over voltage, you can see the message class here is DC link over voltage. So on our PLC, we'd get the diagnostics saying the name of the drive. So whatever drive name we've given it, whether it be conveyor 1, conveyor 2, has got a DC link over voltage. So these are all standard, all activated via tick box. Similarly, if we had then a power unit overload, so where we got where it's doing too much work, maybe we've got a pump that's blocked. What you can see now is we've got power electronics faulted, and power electronics faults coming into our PLC diagnostics. And this, as I say, all this diagnostics is done by a tick box, and we'll look at that in a demonstration. Before we take a 10-minute break, I'm just going to have to grab a glass of water because I've got a lot more chatting to do. Is there any questions on anything we've seen in that PowerPoint section for myself, Tim, Phil, or Adrian that wasn't covered or needed more clarity on? Fantastic. I'll take silence as a no then. Feel free to ping anything in. Oh, go on, Tim.
No, I was just going to say, is anyone still there? No, silence is a good sign.
Yeah. If you want to ping anything in the chat, if you don't want to ask it directly, then feel free to ping it in the chat. I'm going to take a 10-minute break now. I'll be back here at 10:50, so just over 10 minutes. So 10:50, we'll kick off with the next part, which is the live demonstration. All right. See you all in a sec. Just one more minute, guys. Wait for everyone to join us back at 10:50, and then we'll get started with the demo. All right, guys. By my watch, that's 10:50. So we'll dive out of PowerPoint presentation and we'll dive straight into the TIA portal. Just to save a little bit of time, I've already started a project and gone into the project view. From here, what we're going to do in the first stage is we're going to configure all of our hardware and our network and included diagnostics as well from the drive. What we can do is we can go to, we can add a new device here by double clicking add new device, or in the network view, we could have a look and open up our drives and starters, and we could find our SINAMICS drive that we really want in the portfolio. What's much easier though is because I've got a Profinet connection from my PG directly to my drive via my S7-1500, is I can go to my online access integrated 210 port on my network adapter, and I can say update accessible devices, and my PG will then do a ping on that network to see what devices it can find. What you can see is we have our PLC on there and we have our drive on there. So straight away we've got information about our devices. We can even see what their IP addresses are of the devices as well, so to make sure we've got no IP clashes. If we have, we can go on to the online diagnostics and set a new IP address if we need to avoid IP clashes. And we can go to our online and diagnostics for our drive. And straight away, this takes us to this view here where we can have a look at as our diagnostics general. And this tells us we've got a G120C. This is the part number. This is a module description. So what are we talking? Profinet, Profibus, the serial number of the drive, what firmware we're running on, so on and so forth. So this is a really good snapshot of information of what drive it is we're talking about. Now we want to bring that drive into our hardware configuration. We can do this simply by going online and upload device as a new station. So as you can see, with a short amount of time, that's taken all the hardware configuration and all the parameterization of this drive directly from the hardware into our TIA portal with 2 clicks. If you compare that to another or a competitor's drive, and you wanted to engineer the system in TIA portal, of course, you'd have to go in, find the GSDML file for that product, and then you'd have to go into your options, manage GSD file, install the GSD file, go to devices and networks, find other field devices and drill down and find the drive that you want. As I said, we just did update accessible devices, drive 1, online diagnostics, online and upload device as new station. And there we have our drive, our new drive in our TIA portal. What I'm going to do then as well is I'm going to bring in our PLC. What I need to do is I need to go on my online and diagnostics again and have a look at my PLC information. I can see I've got a 1513F. Here's the part number, and this is our firmware version. So we're on the latest firmware version of 2.8.2. What we can do then is we can go back to our device and networks, and we could find the PLC here. But what I'm going to do is I'm going to add a new device controller. I'm going to give it a sensible name. So we're going to base this on a conveyor application. So we're going to call this conveyor main controller. So this is going to be our central controller for our conveyor system. I can go to S7-1500, go to CPU, scroll right down to the bottom, and we have this unspecified CPU. If I click on this, you can see we've got a ghost product. We select firmware version 2.8, and it's important that we match the firmware version of the actual PLC here in the project. So if it was an earlier version, we can go back. Mine's a 2.8 and click OK. What that does then, it brings in this ghost product, this ghost S7 1500. I'm using S7 1500 today, but it would absolutely work just as well on a 1200. It works exactly the same. I just haven't got one to hand, so S7 1500 is the way we're going to go. And here at the bottom, you can say we've got this detect. Because I'm obviously online to my PLC and drive, I can then use the detect feature. Going out on my 210 port, I can start a search and that will look on the network for any S7 1500s. Here it's found my 1513F at this address. I can flash the LEDs, which then will flash the LEDs on the front of the PLC so I know which PLC I'm talking to, and then I can click detect. And what this does is automatically brings in the PLC to the project. If I had a whole rack of I/O on there and power supplies, what that would do is bring in all the I/O, all the firmware version of the I/O and the power supplies in one go. So you can see that would be a really easy and a quick way to upload your devices into your project. This also works with ET200SP. So if you had a remote rack of ET200SP, we do this up here though. We do online hardware detection and Profinet devices from network. That way it will then find ET200SP header module and we can upload that whole station into our TIA portal as well. So if I go back to my device and networks now, what we've got is we've got our main controller PLC and our one drive. We're going to simply connect these two together with a simple drag and drop. And we have now connected our PLC and our drive together. What I'm going to do is I'm going to go into the properties of the drive. And what we have here is we have our general information where the drive is going to be named conveyor in feed 1. So if I had 3 in feeds, I'd have conveyor in feed 1, 2, and 3. So I'd have 3 different names. Now, this is really important that we give our drive sensible names. It seems a bit fictitious, but this is the name that's then used if I go to my Ethernet address as the Profinet device name. So what that means is when I get a fault on my conveyor in feed drive, that the PLC then calls it conveyor in feed 1. So all my faults associated with this drive come into the PLC diagnostic buffer with the given name that we give it in the project. And that's really handy for readability and usability. So always give our drives a sensible name. Go back to our drive now. Towards the bottom of the list of options, what we have is our module parameter. And as you can see now, it says activate channel diagnostics. We've got Profi Drive standard diagnostics selected. And this is what I was talking about right at the very end of the presentation, where we get standard diagnostics, where if we've got a hardware fault, that is brought back into the PLC. So all of our faults are categorized into, I think there's about 20 different categories. And our PLC then picks up these categories literally by having this box ticked. If I bring in another drive, so I'm just going to copy and paste this drive for now. What you see is this drive's not networked. So if I went to the drive there and the module parameters, as default, this is set to inactive. The minute I then drag and drop that onto my PLC, so I network that drive, modify it with the next free address in the same subnet. If I go back to the drive now, you can see that the Profi Drive standard diagnostics has been automatically activated for us. So this happens as default for us. TI portal starts to do some of the engineering in the background. Of course, yeah, we could, if we wanted to, we could inactivate the diagnostics. I don't know why we would, but we do have the ability to do so. Just going to delete that second drive out because we don't need it for this application. So that's our PLC and our drive network together. What I'm going to do as well, I've got a HMI that resides in my library. So what I'm going to do is I'm going to go to my libraries here and I'm going to open a new library. We have created a library, which is our HMI library version 16, and I'm going to open that library into our global library. What you can see is when I open up the global library under master copies, we have a full HMI. So this is the HMI configured with an IP address, all the screens configured and everything that we need. So this is a real quick time saver. If I'm doing conveyors daily and I want a pre-built HMI with all the engineering done, I would really recommend using libraries. And I'll touch on this a little bit later once we've commissioned our drive, how we can actually do or reutilize this library multiple times. So here's our HMI. We then want to network our HMI to our drive. Of course, we can drag and drop. But what's a real time saver is if we go to connections up here, when we generate a HMI connection between the HMI and the PLC, in one click, it says, do you also want to add it to a subnet? I absolutely do, because these are going to talk over Profinet. So if I click the PNIE network, what you see is it has generated the HMI connection between the HMI and the PLC. And if I switch back to the network, it's also connected it to the Profinet subnet as well. So it's a real time saver. One click will do both actions. We could, of course, manually create a network connection between the HMI and PLC and then create the HMI connection separately. But as a time saver, do HMI connections and it will generate that automatically, that network connection for us. Okay, so that's pretty much our network configured. What I'm going to do is I'm going to download this down to the S7-1500. I'm going to put in the hardware configuration into the PLC. Now, there's multiple ways to download to the PLC. Oops, I always forget this. What I need to do is every time, because I've got a safety PLC, it asks me for a password. I get this list of faults and it says password must not be empty. If I click on the green arrow here, it jumps me to exactly where the fault is. And here it is. I should have entered a password here, or I'm just going to give myself full access in this instance to avoid that in the future. So I go back to device and networks. Again, I'm going to right click this time, download to device. As I say, there's multiple ways to actually do this. Download to device hardware configuration. We're going to compile the configuration. Everything's happy. Click load. That will download all the information to the PLC. And then I'm going to start the PLC up now. If I could show you my drive that I've got in front of you at the minute, it's got a flashing bus fault light, BF light, because the PLC now is looking for conveyor in feed 1, which in this instance doesn't exist. This drive here as default is called drive 1. So the next step, what we have to do is the PLC is looking for conveyor in feed 1. This drive's called drive 1. We will then have to assign the Profinet device name to our drive system. Just wait for this to finish loading and start up the CPU. Some patience is required with TIA Portal sometimes. It's Colin. I've just seen your comment of is the Profinet connected via a switch. It's not at this point. On my 1500, I actually have 2 ports, and on my G120C, I also have 2 ports. So at the minute, I'm out of my PG into my S7 1500, out of the second port on my 1500 to my drive. Similarly, I could go from my my PG to my drive, and then from my drive to my PLC, because, as I said, each device here has 2 ports on it. So we can actually use our G120C as a mini switch, as it's got 2 ports on it, so we can pass the Profinet directly through it. Hopefully that answers your question, Colin. So that's the hardware configuration downloaded to the PLC. What I then need to do, as I said, is assign my device name to my drive as well. So we've got the button at the top, which is assign device name, or similarly, I can right click on the front of the drive here and go assign device name. What we're looking for is we're looking for anything on the network called conveyor in feed 1, which is of type G120C. We update the list, and that's effectively doing a ping. So I've had multiple drives on here. You could see this table will probably fill up quite quickly. I've only got 1 drive, which keeps things simple. What's brilliant is we bring back the MAC address, which is printed on the side of the drive, so we can see exactly which drive we're talking to. And we also have this same flash LED symbol where we can tick that box and the LED sequence on the front of the drive will start to flash. What you can see is its default name is drive_1, but we actually want it to be called conveyor in feed 1. So we click assign name. What you see is now this drive will change its Profinet name to conveyor in feed 1. Again, a sensible name, because this will really help us when it comes to diagnostics and come to our code later on, and close. And what's happened now is my bus fault light on my drive instantaneously has stopped flashing, because the PLC says, can I see conveyor in feed 1? And conveyor in feed 1 has now got its new name and has gone, yes, here I am, conveyor in feed 1. So that's our communications established. So that pretty much concludes our communications and network configuration. At this point, I'm just going to ask, is there any questions before we move on to commissioning the drive? So is there any questions on any of that lot? Nope. Fantastic. Okay, what we're going to do then is we're going to move on to commissioning our drive. So if I open up the drive here in TIA Portal, it is worth noting that I do have in my installed software, I'll just show you this dead quick, is I do have Start Drive Advanced installed. Start Drive or SINAMICS Start Drive is a free option install on top of TIA Portal, so you can install that for free off our support site. That gives you full access to all of our drives portfolio in the hardware catalog and everything else. So we do need to have that installed to be able to do what I'm doing today. The advanced part is a licensed extra, and that only shows us the acceptance test here. That's effectively the only difference between Start Drive Free and Start Drive Advanced. So we'll look at that in a little bit more detail. Thanks for picking up the questions, Phil. It's hard to keep an eye on the questions at the same time as doing the demo. Thanks, Phil. So what we can see, we open up the drive here and we've got a list of options. What we're going to do is ping to our commissioning, and we're going to go to our commissioning wizard, and we're faced with what's called application class. I'm not sure this means much to many people. When I first came to it, it didn't mean anything to me. It's probably a bad translation, but we get this drop down box of whether we want to be an expert, whether we want to do standard drive control or dynamic drive control. What's brilliant is the text underneath. So standard drive control is for pumps, fans, compressors, beam technology, mills, mixers, kneaders, crushers, agitators, horizontal conveyors, simple spindles. Well, I've got a horizontal conveyor, so it sounds like standard drive control suits my application. Do I want vector control? Is my power up to 45 kilowatts? Yes, I've got a really small G120C here, so yeah, less than 45 kilowatts. Ramp down times between 5 and 10 seconds. Yep, I don't want it accelerating too quick, otherwise my products might fall off my conveyor system. So it looks like standard drive control suits my application. If I switch it to dynamic drive control, pumps and compressors with the displacement machine, no, that's not me. Vertical conveyor with encoder, no, that's not me. So now you can see that this doesn't suit my application. You know, ramp up times less than 2 seconds. You can see that this is really dynamic. What this does is set a whole host of parameters in the background for you. So it is worth just spending a bit of time on thinking, do I need dynamic drive control or standard drive control? And as I say, different ones suit different applications. Standard drive control suits my application, so that's the one I'm going to select. Then we've got 3 options here in the commissioning wizard. We have standalone drive, which basically turns off the communications and it looks towards its digital inputs and analog inputs for speed control, start, stop, so on and so forth. I've got the middle option where my PLC is going to send data to my drive, but the ramp function generator is still going to stay in my drive. So my drive is going to ramp up and ramp down, but the PLC is going to say at what speed to run at. Or I've got the top option here, which is what we typically use for technology objects. We've got our PLC with a ramp function generator built into the PLC. So over this communications, what we've got continuously is we've got a new set point being generated to control the ramp of our drive. Well, for what we're going to do, we want the middle option. Okay. Because I selected the middle option, it defaults as we want field bus communication. Absolutely, I want Profinet. I want my drive being controlled over Profinet. And it says, what telegram do I want to control or use to control it? Well, as I said, we have now the new blocks for telegram 20 or 352. So if we were using either of these twos and we wanted more details, then we could change the telegram here. but for what I'm doing, standard Telegram 1 is enough for what we need for today. So I'm going to leave that as default. What we say then is, what standard are we meeting? Well, we've got an IEC motor, so that's perfect for my application. And what's the drive unit line supply? This is really important that we get this right, because that sets the upper and lower limits. Sorry, 1 second. Sets the upper and lower limits for our DC link voltage. Okay. So I haven't got 480 volts here. I've got 240 volts or 230 volts AC in the house. And I've got a voltage doubler inside my demo kit, which then tricks the drive into thinking it's seen 480. So I need to put that at 480, otherwise I'll get a fault on my drive. But as I say, it's worth testing your line supply and controlling that. Then we move on. We've got braking resistor. Do we have the option for braking resistor? Yes or no? If we do want a braking resistor, so if we want to do a fast ramp down time and dump our energy onto a braking resistor, we have the option to pump the power in here. If not, then we can untick this box. So I haven't got a braking resistor, so I'm not going to select that. And then also, what filter have we got? So this is a filter between our inverter and our motor. So for example, if we've got a really old motor that we're not sure we'll be able to cope with having an inverter feed it and the front end, we could put something like a sine wave filter in there. And this helps when we do our motor ID to compensate for the inductances. But I have got a filter at this instance, so I'll leave that as no filter. Next, we've got the motor data. Now, because I've got a Siemens drive and a Siemens motor, built into our Siemens drives is our full catalog of Siemens motors. So what I can do is select from order number, and I can go down and it's a 1LA7. And that shows us then the catalog basically of motors, and I know it's a 1LA 7060 for AB10. So if I'm buying a Siemens motor drive combination, you can see it's much quicker to configure our motor information using the built-in catalog. Of course, we can use a third party and enter the motor data manually, and therefore we can read off the motor data plate or the motor rating plate and pump that into our inverter. It's absolutely no problem. We can also say then what type of temperature sensor do we have wired into our drive, which then will activate the temperature monitoring built into the drive on terminals 14 and 15. Okay. Do we have a motor holding brake configured? In this instance, we don't, but if we did, we could say we have a motor holding brake like sequence control. So the G120C will use a digital output to control that motor holding brake. So the inverter will start to magnetize the motor. The motor holding brake then will be released, and the motor then, will start to accelerate to avoid things like droop. If we wanted that, if we had a modular drive, so if we had the G120 modular, for example, that has dedicated terminals on the power module for controlling the brakes, so it wouldn't have to use one of our digital inputs, and that would be a separate option on there. Okay, I haven't got a motor holding brake, so I'm just going to skip next on that one. My reference speed is 1500 RPM. For anyone who was eagle-eyed in my motor section will have seen my motor is rated at 1350 RPM. So why is it said the reference speed and the maximum speed here is 1500? If this motor was fully loaded, run direct online, so fully loaded with torque, run direct online, then the flux in the motor would be turning 1500 RPM, but the rotor itself would be running at the rated speed of 1350 because induction machines run off or work off slip. So that's how it would work if it was run direct online. Because we're inverter fed, what we're actually controlling is the output shaft speed. So what we can do is overspeed the flux in the stator to make sure we achieve the full 1500 RPM on the output. And that's the beauty of having flux compensation built into all of our drives, the standard. So, and it's worth making note of this reference speed as we're going to need this later on. My ramp up and ramp down times are going to change to 5 seconds. So it's a little bit quicker in its response. We have an off 3 ramp down time, which is sort of a quick stop. which I'm not going to use at this point. And then our current limit, which is automatically calculated for us. Okay, so click next on this. What type of application have we got? Have we got a speed dependent load, such as a pump or fan? No, we've got a linear load, which is our conveyor. Then we've got the option to do a motor ID. Are we going to run a motor ID at standstill? Are we going to do a motor ID at standstill and then switch straight to operation? Nope, I'm going to stick to motor ID at standstill, which is the middle option. I always recommend doing a motor ID because the drive will send out test pulses and it'll do a sanity check that you've put in the right motor details if you've entered them manually, but then it'll also calculate things like motor inductance and capacitance inside the motor itself and create a really accurate motor model. And it'll use that for things when it's like calculating the motor temperature. So we are using calculated motor temperature. Motor ID will help to create a really accurate motor model. So recommend always doing a motor ID. Click next. We get a nice summary of all the settings that we've done. And then we can click finish. What you'll note here is I'm working offline. Everything here is all grey and grey across the top. We can do the commissioning online if we want, but because I've done it offline, if I just show you a quick example, if I go to my parameter view, for example, if I go to parameter 210, so parameter 210 here in the parameter list is, sorry, don't want to bore you, parameter numbers is our line supply voltage. You can see offline that's 480. That's what I put in the commissioning. If I go online to the drive now, what you'll see is that will be the default value of 400 when that makes the connection. Oh, just wait for it to make a connection. There you go. So that's 400. So all that commission that we've done is only existed offline. So what we now need to do is we need to download the offline parameterization directly into the drive. So then what we have is an offline copy and an online copy that are both identical to each other. Okay. So just wait for that to download and all of that then parameter to go in. And what I'm going to do after I've commissioned it is I'm going to do the motor ID using the control panel. And this is another point that we can touch on is we can start to commission things in sections. So for example, now I have commissioned my G120 and I want to test that will run standalone. I haven't put any application code in my PLC and I'm not really, I'm not bothered about that. I just want to be able to see if I can turn my inverter, turn my motor, and is it gonna run. This was good for checking things like, is it going to turn in the right direction? So if I go to the commissioning here and I go to the control panel, what I can do is I can just get rid of some of these windows so you've got a better view. Activate master control, accept. And you can see now this will all go top saying you are now master control. So now I've taken control of the drive. You can see I've got this bauble here saying motor measurement is active. So when I click forward, what you'll hear is some high frequency spikes and coming out of the, oh, I've got a fault on my drive. Sorry, I've got a fault coming on my drive. Rectify the fault. I don't know what the fault was there. Try that again. So set the enables, click forward, and we should do motor ID. Oh, it's unhappy about my motor data. Let me just try that again. Give me 1 second. What I'm going to just do is I'm just going to run through that commissioning wizard one more time and just double check my motor data because it's not happy about something I've entered. Standard drive controls fine. Set point, middle, yeah. Default the set point, field bus, drive line supply 480, line filter. 4.2, yep. No temperature sensor. It's 107. Let me just double check. My motor data is correct. Yep. No motor holding brake. 1500 RPM, 5 seconds up and down. Yep, perfect. Identify my motor at standstill and RAM to ROM, finish. Okay, so that was just running through the commissioning wizard online just to make sure I entered all the parameters correct. They all seem to be correct. Just wait for it to do a RAM to ROM. Activate master control again from the control panel. And click forward. It is really not happy. It doesn't help that I've got my motor disconnected. Sorry about that. There we go. Motor now reconnected, which is probably going to be the problem. It can't see a motor at all. If I set my enables again and click forward, you can now hear, if I put a mic to it, high-pitched squeaks. So that's sending out different frequency and voltage spikes, measuring the current and creating a motor model on the back of it. So once that's completed, as you can see, the motor ID bauble here has disappeared and it's reset my enables. So if I set now my drive enables and put a speed set point in, say 100 RPM, for example, and click forward, my inverter is now turning my motor at 100 RPM. I can increase and decrease the speed. Put 300 in, for example, it will now increase the speed. And I can see that on my operator panel here. I can check the direction, so I can run it forward, run it backwards, make sure they both turn in the right direction, and I'm happy with that. Okay. I'm going to click off now and just stop that and deactivate master control. So that's the drive commissioned. What we're going to do now is we're going to do the safety commission of the drive. We do this via the parameters. So it's worth noting that we are working online now. So I'd always recommend doing your commissioning online. We've got the functional view. So the parameter view is just a list of all parameters. I wouldn't recommend doing that unless you really want to dive into all the parameters. In the functional view, if we go to safety integrated, you can see we can select our safety functionality. So at the top here, we've got start safety integrated commissioning. So yep, we want to start the commissioning and it says enter a password. The default is 0. You can change this to be your own custom password so you can protect the safety functionality to your organization. I'm going to leave it as default, so I'm going to leave these blank so the default password 0 stays, otherwise I will forget it. And we can click OK. And then my drive straight away goes into fault because we are starting the safety commissioning. We only have basic safety on G120C, so safe torque off. So if I had extended safety, so if I had a modular drive, I could have extended safety on there as well. If I click on basic safety, we then have these options here below us. So the control type, if I click on that, it says via terminals, via ProfiSafe, or a combination. So we could have a combination where we've got a local e-stop directly on the drive, but then we've also got ProfiSafe, which is a global e-stop issued from the PLC. I'm only going to stick to via terminals, so local safety via terminals. As I said, dual channel e-stop wired directly into the front of the drive. Okay, and then we click on save torque off here, and we basically follow the wizard through, which saying if we've got if our digital inputs go low, or we have a fault on our safety channel, you can see STO will become active, and therefore we could also then tag this up to an output. So for example, we could say if STO becomes active, we could select, for example, the source. This is the source's digital output 0. So when I hit an e-stop, an output on the drive comes on to say that the digital output is active or that STO is active. So we can use that for further functionality. Our test stop timer, so built into the drive is a test stop timer where after this time elapses, this 8 hours, we can put any value in that we want up to about a year. And this comes from your safety evaluation. So you evaluate your requirements for your safety machine and therefore what time should we put into this test stop timer. When this test stop timer counts down to 0 effectively, we get an alarm on the drive to say we need to test our safety functionality, i.e. we need to press the e-stop and reset it to ensure that we get dual channel and no discrepancy in our safety channels. This is just a safety check on our output. And again, when the test stop is required, we could connect this up to a digital output to say that a test stop is now required. What we've got in our FDI, FDO and ProfiSafe settings here is our discrepancy time between the two channels, and also an input filter for things like debounce. And then the very last part, if I did click on acceptance test, that would take me through to the acceptance test wizard, because I've got the license for Start Drive Advanced. But we're going to have to do a safety acceptance test on the drive, and effectively full description of what a safety acceptance test is for STO and how to achieve one is available in our safety manual, which is fantastic. So that just walks you through how to do a manual safety acceptance test. I'm going to end the safety commissioning now. So I've got to the end of my safety commission. I'm going to end that. And if I showed you the LEDs on, yes, I want to do a RAM to ROM as well. So that's good, because I want to store them settings retentively. So what's on my LEDs now on my drive is the ready LED is flashing red, and my safe LED is flashing amber. Flashing amber safe LED means that we are in a safe state, so the drive will not run. Flashing ready means I have a fault on my drive. If I go to my commissioning here, you can see that we've got our fault, and switching on is inhibited because of STO. If I then put my e-stop high, for example, what you see now is my safe LED is solid, so we're in a ready to run state, and I can acknowledge the faults here. So my drive now has gone ready to run. My e-stop is depressed, and we are ready to go. If I activate the control panel just to test this, just to show you it working, if I then put in 100 RPM, for example, and click forward, the motor is now turning at 100 RPM. If I hit my e-stop, you can see that we've now coasted down to a stop. And the safe LED is now flashing again on my drive. Reset the e-stop. You can see, or I would describe to you, that my safe LED is now solid amber, not flashing. We're back ready to run, but the drive did not restart. So it will not automatically restart, and I'll show you that in a little bit. So that's my drive commissioned. Now I've plugged my motor back in, and that's my safety commissioned. The very last part is, as you see, I did this online. So we're working online in the drive. I now want to take a backup of all these parameters into my project. Oh, if I deactivate master control, sorry, first of all, so I can't do an upload while I'm taking master control. While I'm online, click the upload button, and we take a copy and a snapshot of all them parameters and bring them back into our project. So that way I have an offline copy of the drive as commissioned. I can go offline now. And then if I go to my device and networks view, if then I had 3 in-feed conveyors, all exactly the same size, what I would do is simply copy and paste. And that's taken the hardware across, and it's also taken all of the parameters that we've done. So all the safety commissioning and everything, copy and paste for our second drive. Of course, I would rename it conveyor in feed 2. Again, copy paste third drive, and this one, oops, would become conveyor in feed 3. So you can see how quickly now we can start to build up our portfolio. If conveyor in feed 3 was going to be a larger drive than what we've commissioned, I can right click and select change device. And then I can go for example, a bigger drive. So I'm going to go for a 15 kilowatt now, and it will change my G120C from my piddly little 0.75 kilowatt up to my 15 kilowatt. So again, keeping all the parameters the same, but upsizing the drive as well. So now we've got a 15 kilowatt drive here. We would obviously have to run through the motor parameters again, because they're now going to be different for 15 kilowatt, but you can see how easy now it is to reuse engineering. Okay, I'm just going to delete that 15 kilowatt, for example. If I then wanted to store this in my library, I can then drag and drop that whole drive into my master copies, and that then can be there available for me to drag and drop back in anytime I want to add a new drive. So you can see how we can really easily do reusability without having to reprogram our drives time and time again. So that's the section on commissioning the drive. Is there any questions at the end of that section before we move on to programming the S7-1500 PLC?
That feature about changing the device type, is that new with version 16? Because I don't remember that being available with earlier versions of TA.
No, it has been available for quite a long time, actually. I can't remember when it came in, but it's definitely not a new thing in 16. It was there in 15 and before. Another common question just on the back of that one, Paul, is we do sometimes get where we're not sure what drive it is we're going to get. It might be a retrofit, so it might be an older drive. I'm just going to dead quick show you. If I bring a drive in from the catalog here, it will default as the latest firmware version. If I just pop information here, it's worth noting this. So it defaults as the latest firmware version, and we can't go backwards. Okay. So what we'd have to do, what we can do though, is we can bring in, for example, a 473, so an older version of the drive. Yep. Do all of the commissioning, so on and so forth, and then when we get our hands on the drive, it might be a 479 or 4710, for example. We can right-click, change device, and we can select exactly the same drive. I can't remember which one it is I selected. I hope it was the smallest one. Yep. And you can see now, if it's a 479, we can go up firmware versions. So it is worth noting we can't go back firmware versions, but we can go up firmware versions. Does that help?
Yeah, it's good. Thank you.
Pleasure. Any other questions on the hardware configuration? Nope. Okay. So what we're going to now move on to is adding the control blocks to our S7-1500 PLC. So what we're going to do is we're going to add a new block, and we're going to call this conveyor. Oh, if I can spell, conveyor control. So this is our conveyor control block. It's going to be a function block, and that will come with an associated data block, which we'll use to interface into our SINAMICS. So here's our conveyor control block brought in. We'd give it a sensible name, such as Speed control of conveyor. Yeah. So we've given it a sensible name for readability. What we'd usually have to do is go into our libraries, and we'd have to open up our library to control our drive. What I think is fairly new is if I go to my standard instructions, we have this optional packages. Because we've installed Start Drive in TIA Portal, in our optional packages, in our SINAMICS portfolio, we have our SINASpeed block. So here's our standard SINASpeed block built into TIA Portal in our standard instructions for us. So we can drag and drop that block here into our function block. We're going to create a multi-instance DB for best use of our resources. And there we have created our SINASpeed block. I'm going to go through the pins one by one when I tag them up. But what we're going to do is dead quick. I could create all the tags up here in the data block area for the function block. But what I'm going to do dead simply is I'm just going to do type them in dead quick. So enable, enable. So that's going to be our start and stop for our drive. So if that pin's high, the drive's running. If it's low, it's going to be stopped. I'm going to have acknowledge fault pin. That does one of two things. It acknowledges faults on the drive, but it also acknowledges faults on the block. We're going to have speed set point. And this is going to be a floating point or real value between 0 and 1500 RPM. Okay. The reference speed. Now, what happens is the PLC or the drive, should I say, sorry, scales its speed between 0 and 100% and sends that to the PLC. So the PLC might see 50%, but 50% of what? So we have to then scale that 50% back to being a real value. So we get back 750 RPM. Dead quick, if we go back to our drive and go into our parameter, here in the basic settings, we have reference variables. Here we can see what our reference variables are. You can see the reference speed is 1500 RPM. And this is what we will use in our block here as our reference speed. So if I just type in 1500 RPM, and that then will ensure that this block scales exactly the same as what our drive is going to scale. If we had the SINASpeed Telegram 20 or 352, we would also need the current and torque and power scaling. As you see, really handy to have all of these built into this really handy view for us. Okay, our config axis I'll come back to, but effectively it's a word of bits that we can toggle on and off to enhance some of our functionality, such as we can run in reverse, we could open the brake, for example. So by changing bits in this word, we can enhance what our SINASpeed block does. As I say, I'm not going to touch on it now, but that's just a little bit of information. Our hardware ID is effectively what driver we're talking to, so I'm going to make that hardware ID. And a legacy thing is we typically have two different hardware IDs, one for the status word and one for the control word. With Profinet, that's all one hardware ID, so I'm just going to use the same tag there. And then coming back out of my block, I've got my enabled, axis enabled. So axis enabled, oops. Sorry about my fast typing. So my axis enabled pin, and if I send a high signal here, I should expect to see this go high when my drive starts to run. Okay, lockout now. Lockout can be that there's a fault local to the drive. We'd also get a fault value on our diagnostic buffer, but also if our drive had local safety enabled, and was in a safe state, we'd also get a lockout. So basically it means the PLC can't control the drive at this moment because there's something that's inhibiting us from running. Okay, and that's what we call lockout. So I'm going to keep that terminology. I'm not going to call it fault like I normally do because it's a bit confusing. Lockout just means we can't actually control it. Actual speed or speed actual is going to come out as well. So we'll see what actual speed we're running at. So if we're sending 1500 RPM in here, we should see 1500 RPM come out of here. We've got our error of our block. So this will tell us whether we got an error. We've also got status and diag IDs. I'm not going to bother tagging them up though. So as you can see, I've generated all these tags and they're all in red, which means none of them have actually been created. So I'm going to right click here and define tags, and in one go I'm going to define all of them. The enable is going to be a local input to my block. My fault acknowledge is going to be a local input. My speed set point is going to be a local input. My hardware ID is going to be a local input. My enable is going to be a local output. My lockout, a local output, speed actual, a local output, and the error is also going to be a local output. So dead quick, I can click and define all of these in one go. And you can see it's populated the data block up here at the top. So that's really, really quick way of tagging up a block. Okay, so that's my block tagged up. I'm going to go to my main OB and call my function block, which is what most people forget to do. So I'm going to drag and drop this conveyor control DB, and the DB will be automatically generated for us. And here is our block with our nice simple interface of enable, acknowledge fault, speed set point, hardware ID, and then axis enabled, lockout, speed actual, and whether there's an error on our block or not. So I'm going to just call this conveyor in feed one, speed control block. So again, sensible name. Which really helps with readability. And to interface with this block, what I'm going to do is I'm going to add in a data block, and I'm going to call this my HMI interface. So I'm doing using a data block rather than tags, as it's probably the preferred way of doing so. I'm just going to split my screen here. So I've got my HMI interface data block on my left and my block on my right, just so I remember what the tags should be called. So I've got my enable pin, I've got my acknowledge fault pin, I've got my speed set point. My hardware ID I'm going to leave because I'll tag that up from somewhere else, and I'll show you where that comes from in a second. I've got my axis enabled pin, I've got my lockout pin, and I've got my speed actual pin. Now, it's generated all these as bools. Of course, my speed set point should be a real. But for my HMI, I've used, it's going to have to be an int. So I'm just changing both of these to integers. Because on my HMI, I have a gauge and a slider. Neither of these two accept integers. Accept real values. They only accept integers. So I'm going to have to create these as integers in my HMI interface data block. Drag and drop from my data block to my control block. So HMI enabled, lockout, speed set point. So there's my block all tagged up, apart from one element, which is the hardware ID. What you might notice is here on the block, you can see we have this this grey symbol here. And what that means is it's converting our HMI set point interface as an integer directly to a real for us in TIA Portal. So we don't have to manually create a block to transfer from one data type to another. TIA Portal will do that for you automatically. So this is converting our integer to a real. And if we hover over it, it should tell us what's happening. So there you go. It's converting from integer to real. So that's really handy for TIA Portal to see that for us in the background. Okay. So our very last part is, okay, what block is this drive going to control? Well, in our PLC tags, if we go into show all tags and system constants, in our system constants, automatically generated for us by TIA Portal is our conveyor in feed 1. Again, sensible name for our drive, conveyor in feed 1, Profinet interface, standard telegram 1. So I can drag and drop from that PLC tags to my main block as my hardware ID. So when I see and look at this block, you can see straight away that this block is controlling conveyor in feed 1, Profinet interface, standard telegram 1. So the readability is fantastic by using this automatically generated tag. Of course, I could type in 266, which is the hardware ID that it's actually using, but you can see how the readability has gone straight away. Okay, so back to this, drag and drop from the system constants onto our hardware ID. So there's our block, all configured and ready to run. I'm just going to download this to the PLC now, and then I'm going to take control of the drive and show you the block working. Similarly, going back to reusability, if I had multiple conveyors, so if I had 3 in feeds, for example, I can then drag and drop my conveyor control block again and create a new instance DB, for example, which I'm not going to do just to keep things simple. But here we've got another version of the block for another conveyor. Similarly, I can take that block and I can put it into my library. He says, I can't remember where to pop it. Oh, sorry, I've got to drag it from here into my master copies. So in my library, I've now built up my HMI, the drive fully commissioned with safety, with all the motor data and even the control block all in my little library there. So it's really handy to have that library available. If I go online now to my PLC after downloading, I just need to re-download that because I just played around with the with add new block. Sorry. As you can see now, everything is good. I had a fault on my drive because I turned the PLC off or it went to stop. So my drive signals a fault because it lost its master. In my main block now, if I put my goggles on, you can see I can see my application code. So we've got our enable is false, and therefore our drive isn't running. Our drive isn't in lockout, so it's available to run. Our speed set point is 0 and our speed actual 0. First thing I'm going to do is right click, modify and put a speed set point in. So I'm going to use 250 RPM just to mix it up because I used 100 every other time. And then I can right click here, modify to 1. And you can see now that we've ramped up to 250 RPM and our axis enable has become true. So this block is now controlling the speed of our drive. If I want to increase the speed, I can then modify the operand. Sorry, I'm just going to shout over the drive here and for example, put 1000 RPM in here, click OK, and that goes straight to the drive, and we start to ramp up to 1000 RPM. So you can see the drive is now responding to these changes of set points instantaneously. Yeah. Again, put that down to 100, and we'll ramp back down to 100 RPM. With the drive running then, if I hit the e-stop, so this is local e-stop to the drive, you can see straight away that the drive goes into a lockout state and our speed actual is 0. So despite our enable being on, so our block is trying to control our drive and the drive receiving a speed set point, it is not responding to the control as it's now in safe torque off. If I reset that e-stop, you can see that the drive has not restarted. So despite that true staying high the whole time, the drive has not restarted. What we'd have to do is send that signal low. You can see now the lockouts come off and send the signal back high. And we're back into operation. Fantastic. So that was just dead quick setting up speed control using the standard SINASpeed block that's now incorporated into your instructions tab here in the optional packages under SINAMICS, and that comes as part of your start drive installation. Are there any questions on any of that when it comes to programming the PLC, creating a little function block to control the drive using the SINASpeed block? Any questions on any of that, or any questions on the functionality that we saw? Silence is golden. Fantastic.
Just one quick question. It's Paul again.
Yep.
Using the SINASpeed blocks, other than the extended options now, do you have to use Telegram 1?
So SINASpeed only works with Telegram 1, yeah, and that's where it was originally limited to. As you've seen, they've now increased or extended that library. So if I just open up the library for the extended, just to show you what's in it, it's worth touching on. They've now increased that to Telegram 20 and Telegram 352. So here you go, SINASpeed, Telegram 20 and 352. If I just dead quick go offline here, to my PLC, and I'll just drag in Telegram 20, for example, just so you can see what it looks like. I think it's worth doing that.
Are those extended telegrams libraries coming version 16, or is it 15? You have to update them.
I honestly can't remember. I do apologise.
It's okay. All right.
I can't remember whether it's 15.1 or 16. I've got a feeling it was 15, and I've had to upgrade it. But then I did start using it last year, so they might have already updated it to 16. I'm not entirely sure. But you can see sort of the look and feel is very similar to how SINASpeed looks and feels. And my point is if you can control a drive using Telegram 1 by simply changing the telegram in the drive and changing the block to Telegram 20, for example, this Telegram 20 block, we should be able to achieve exactly the same. Is that all right?
Yep, thank you.
Yep. What we can do is, if we did want to bring back something that isn't in standard Telegram 1, 20 or 352, what we can actually do as well is we can add a completely separate telegram in either direction, and that comes into a completely separate I/O area. So we can still use the SINASpeed block to control the drive with Telegram 20, for example, but we could add an additional telegram. I'll show you where this is. So in the drive, I go into properties. Sorry, we digress a little bit, but it is a good point, because sometimes the telegrams feel a little bit limited and you want to add a bit more to it. Here you can see our telegrams, standard Telegram 1. I can add a new telegram in either direction. And if I, for example, add a send extension, for example, it can be a completely free telegram, and it can sit in a completely separate I/O area. So I can give it a completely separate I/O address. So then that sits way outside of my standard Sina speed control. Yeah. Better just delete that out before I download it and then mess my project up. Okay, the very last part then is our HMI and tagging our HMI up. So if I go to my main conveyor HMI now in my screens, as I said, this is a pre-built HMI because what I didn't want to do is teach how to create a HMI. This is using our HMI template suite just to give a really nice look and feel. I'm by no means a HMI screen designer, so I apologize if they look a bit noddy. But it saves a little bit of time watching me create something so daft. So here is our HMI screen with our start, stop, reset, speed set point, which I can enter manually or via the slider. I've got my drive enable, drive faults, and also my speed actual coming back on this nice little dial. So what I'm going to do is I'm just going to tag this up. The way I'm going to do this is I'm going to click on, for example, start, and I want to now add functionality. So for my start button, I want to do, when I press it, I want to do set a bit. So my start will set the bit, and the bit I want to start lives in my HMI interface block under enable. Yeah. So this is my enable pin. So when I click start, it'll set the enable bit. When I click stop, it'll reset bit. And that's my enable pin again. My reset, I'm going to use set bit while key pressed. So for as long as I'm pressing that, it's a 1. And as soon as I leave go, it becomes a 0. So it's almost like a momentary push button. Again, this is going to come from my program blocks, HMI interface, and acknowledge fault. My speed set point, I'm going to tag up here as my speed set point as an integer. And similarly, the slider is also going to be my speed set point. Coming back from the drive then, what I want to do is add a bit of animation to these baubles. So I'm going to add a new animation, and it's going to be the appearance I'm going to change. I'm going to tag that up to being my axis enabled pin. And if it's 0, I'll leave it as it is. And if it's a 1, I want to change the color to this nice snot green color. For the drive fault, exactly the same. Add a new animation, appearance, and I'm going to use the lockout pin. So really this should say lockout rather than drive fault. So I apologize for that. If I then change it to this nice red color when it's a 1. So when my drive's in lockout, I'm going to change that now actually. We get that as a red symbol. And then my gauge here, I'm going to tag up as my speed actual coming back. Okay, so speed actual. Okay, so there's everything tagged up. One thing I am going to do is just increase the cycle time of my screens, of my tags, just so that we get a bit more responsiveness when we look at our visualization. So in here should be my my tags I've generated, and we've got 1 second acquisition time, which is a bit too slow for my speed set point and speed actual. So I'm just going to increase that to the maximum of 100 mil, just to, as I say, show a little bit more responsiveness. Yeah, so speed set point, speed actual, increase the speed of them, or the acquisition time of them. I'm going to click on my HMI now. I haven't got an actual HMI, so I'm going to have to simulate it. But I'll simulate my HMI, and then what I'll try and do is at the side here, I will try and get, just delete that a second. If I just pop that up, there we go. So there's my HMI. Oh yeah, that's not a problem. Will it let me go online? No, it won't let me go online. Let me just download that dead quick to my PLC. 1 second, sorry. There we go. go back to my main application code, main OB, and put my goggles on so you guys can see the application code. So there's the application code. Here is my HMI, and as you can see, I can change the speed. As I change the speed on my slider, you can see the speed set point on the left here changing accordingly. So type in 1000 RPM, for example. There we are at 1000, and I can click start. You see my drive enable's gone high, and we've ramped up to our 1000 RPM. If I then change the speed with my slider, you can see that the drive accelerates and decelerates accordingly. Yeah. So we can see all that happening. Put it up to full 1500 RPM. You can see we've maxed out the speed of the drive now. If I hit the e-stop, then the local e-stop widened to the drive, you can see that our enable pin stays true, and we stick into this lockout scenario. Again, if I reset that e-stop, so we should be back into a running state, you can see that that's now that's not restarted. So our drive has not restarted. We must stop it and restart it for the drive to continue. Okay, so that's just showing a little bit of visualization of controlling really simply the drive from our HMI. What I'm going to do now is I'm going to generate a fault on the drive. So when I generate a fault on the drive, that then should send the drive and give some diagnostics integrated into the PLC. So what you see here is that the drive's currently running. We've got a green tick to say everything's happy on the PLC. I've just disconnected the operator panel while it was in hand, which straight away the drive goes into fault. So my ready LED on my drive is flashing away to say my drive's in fault, and you can see the status of our PLC's gone also into fault. So I've got a flashing LED on my PLC now. If I click on this diagnostic button here and drill down to the PLC diagnostics, you can see if I just keep going following the red, you can see I've got a fault on my conveyor in feed 1. If I had 40 drives on here, you could see all the different names of all the drives, hence why naming's really good to see what's going on. We've got conveyor in feed 1 fault, and I drill right down, keep following the red until we get the standard error text. So this is the standard error text, which is a hardware fault for communication, because effectively it was in control by the operator panel. I disconnect the operator panel, therefore it's lost its master. So it went into a fault, communication level fault. As you can see, the description here is vague, but that's typically because it sits within them alarm classes. And hopefully, just to jump through to the alarm classes, if you are really interested in how many alarm classes we have, I'm just going to scroll quickly through this. In the function manual, sorry, I was on it before and then I got distracted and went to a different page. There's a whole list of alarm classes which show us, here we are, up to 20. So these are our standard alarm classes, which are automatically generated by the Profi Drive Telegram for us. So that's pretty handy to have that automatically generated from that little drop down box we saw earlier on. Okay, I now want to get back into a running state, so I'm going to go back to my start screen. I'm going to take my running signal off. I'm going to hit my reset, so you should see the reset pin go high here, and the lockout then will be removed. So that's acknowledging any fault on the block and acknowledging fault on the drive. We click start again, and we're back into operation. Drive's enabled, and we're ramping up to 1500 RPM. And again, we can control the speed now for our application. Okay, just going to stop that now. And are there any questions on connecting up a HMI to control our drive block? Nope, that sounds good. So hopefully that hit all your points. So dead quick recap of what we've done. All in all, just go offline to the PLC. So we went to our online access and we detected our G120 drive from here. We added a new device, which was our PLC, as a ghost PLC, and detected which PLC it was we were using. We used a library HMI to save some time to bring in our HMI from a library. We configured all of the network. We gave all of our devices sensible names, which is really important to utilize for diagnostic purposes. We went to our properties and made sure that we had standard diagnostics enabled as default and set our Profinet device names for our devices. We then moved on to commissioning the drive, including local safety with the commissioning wizard. We went into the PLC and we configured our program blocks using SINASpeed program blocks, and then we went to our HMI and created our HMI screens to control our SINASpeed block and tagged all that up. Okay, that's as much as I wanted to cover this morning. We've rattled through at quite a good pace, actually. If there's any questions on what we've already seen, then I would say fire away now. If anything was unclear or you've got any questions, I'll give it a couple of minutes just in case they want to stay on the recording, in case anyone had similar questions. Then I'll stop the recording and then we can have a more open forum should people wish to ask questions that way. So any questions about the workshop itself or the demonstration? Perfect. No questions on any of that lot then. Right, I'm going to stop the recording then, just so that people might feel a bit more comfortable, and then